Hello and welcome to my YouTube channel. This is Dramani Online Mathematics. If you know you have not subscribed, please subscribe. Share it to your colleagues and let them also enjoy. Support my YouTube channel. Thank you very much. We are going to continue with the partial differential equation. Already we have looked at the first order differential equation. For the partial differential equation. Now we are going to look at the second order partial differential equation. We looked at the classification of the first order. Now I want to look at the classification of the second order partial differential equation. Now, when it comes to the partial differential equation, we are simply saying that the order matters. So, second order means that you have differentiated it partially two times. Is that okay? Two times. So, if I have something like u xx, let me bring a as a constant, plus b uy xy plus c u y plus, let's say, dux equals 0, okay? This is second order partial differential equation. It is second order partial differential equation because the higher order here is 2. And I told you when you are dealing with the first order partial differential equation that when you are classifying the differential equation, you looked at the order. The highest order determines the order there. Is that okay? Or the highest derivative determines the order there. So looking at this one, the highest order is for 2, 2. So that makes it second order partial differential equation. Now, before you look at the classification of partial differential equation, first, I want us to look at nice equation called characteristics equation for the second order partial differential equation. Now, for this nice equation I'm talking about, the characteristics equation, if I write it, some of you may think that you have seen it before, but there's some little difference there. Is that okay? So when I have dy dx equals b plus or minus square root of b squared minus 4ac all divided by 2a. Some of you might have seen this formula before, and they call it what? Almighty formula in our elective math, or quadratic formula. Is that okay? aka almighty formula. But for the almighty formula, what we know is that there is negative attached to the b, but here there's no negative here, so that's the only difference. Aside that, there's no problem with it. Now, with this formula that we have, this formula will always help us to be able to determine the how do you call it, to able to help us to classify them. Is that okay? Help us to classify them. So for us to be able to classify this, we need something from here called the discriminant. So you write the one under the square root, which is what? B squared minus what? 4ac. And this is called what? Discriminant. Discriminant. Is that okay? With this discriminant, the discriminant will help us to classify the second order PDE. Now, for the second order PDE, can be classified into only 3 parts, okay? 3 types. So the first one is hyperbolic. Hyperbolic. The second one is parabolic. And the third one is elliptic. Is that okay? Now, how do we use this? The discriminant to classify the second order PDE under hyperbolic, parabolic, and elliptic. Yes, I'm going to show you, and this is very simple, okay? So what you're going to do is that if this hyperbolic here is, okay, let me come back here. If the discriminant given minus 4ac is greater than 0, then we name this as what? Hyperbolic. If the discriminant given is less than 0, then we name it elliptic. And if the discriminant given is equals to 0, then we name it what? Parabolic. Is that okay? Yes. So this is how we classify them. You've seen that when the discriminant is greater than 0, it is hyperbolic. Less than 0 is elliptic. Equals to 0 is what? Parabolic. Now with this here, somebody might ask, Where can we get our B? Where can we get our A? Where can we get our C? This is very simple. You could see this thing here. The coefficient of the uxx is our A. The coefficient of uxy is our B. So you should take note of this. The B is always for the uxy and the C is always for uyy. Is that okay? So when you pick those coefficients and you substitute into the discriminant and you get what? A number, let's say being greater than 0. When you say numbers are greater than 0, that means we are talking about positive what? Numbers. Then we can say that it is hyperbolic. When a number is less than 0, means that you are talking about negative numbers, then it's what? Elliptic. And then when it is exactly 0, then you are talking about what? Parabolic. Is that okay? Very good. So now let's look at some examples. Okay, guys, let's look at this example. Classify the following PDs. Uxx minus 3uxy minus 10uyy plus 5ux plus 10uy equals 0. Okay. Now, when you hear classify the following PD and you realize that this is in the second order form, you don't need to think about the first order classification. No. The only thing you need to think about is what? The second order classification, where you think about the hyperbolic, the parabolic, and that of what? Elliptic. Is that okay? So the first thing we are going to do is that we are going to start with the first one, and we are going to start with identifying our A, B, C. So looking at this one, is that okay? So our A here, so I'm doing the 1. Our A here is 1. Is that okay? Our B is -3 and our C is -10. These are first order. We don't need them, okay? We don't need them. So what you're going to do here is that we want to classify them. So first thing, you find the discriminant, which is B square minus what? 4AC. So B squared is what? B squared is 3. So when I square 3, you know what you get? -3, then you square. Minus 4 multiplied by. Now, let's see something here. C here is 10, right? So we are going to have A is 1. So we are going to have 1 times -10. This is what you are going to have. So that we have, this will give us +9. Negative times negative giving us +40. Is that okay? So in this case, our discriminant is what? 49. When I add these two, I get 49. Now you see that this 49 is greater than what? 0. Is that okay? So since the 49 is greater than 0, you can say that this is what? Hyperbolic. So you conclude by saying that since the discriminant, or you can just go straight, b square minus 4ac is greater than 0, the said PD, okay, I don't want to write everything, is hyperbolic. Is that okay? So the second one, we are going to have, where is it? So solution, we have A to be 2, B to be 3. So what to be C? C is also 3. Therefore, looking at our discriminant, which is b square minus 4ac, our b is 3, so that will be 3 squared minus 4 multiplied by 2 multiplied by what? 3. So we have 9 minus 2, 3 is 6. 6 times 4 is 24. Is that okay? Yes. And 24, 9 minus what? 24. What answer are you going to get? You are going to get negative what? Answer. Is that okay? Negative answer. Which will be negative what? Is it 13? Yeah. You have negative 13. Negative 13. So if this is going to be the case, what happened here is that this is negative. Okay? Forget about the number here. Since we are getting answer to be negative, then we can say that the PD is what? Elliptic. Since the discriminant, or b square minus 4ac is less than what? 0. Is that okay? Yes. So you can try your hands on the last one and see. Is that okay? Yes. Let's look at the last example. Okay, now let's look at the second example. Determine the region of all points at which the PDE, this PDE, is hyperbolic. Okay. Now, the first thing that we need to do, since we are talking about hyperbolic, we need to identify our A, B, C, so that you can get our discriminant. Okay. So, what we are going to do here is that our A is giving us what? Y. Our B is giving us what? So, this is negative x minus y. So, if I multiply the negative 2, I get negative x plus y, like this, right? And remember, I can write it as y minus what? X. Good. Then our c is equal to negative x. So per this, you know that the formula of finding discriminant is b squared minus what? 4ac sharp. So in this case, this is equals to, my b is this. So I'm going to have y minus x all square minus 4. Now a is y, c is this, negative x. We are going to have y multiplying by negative x. So this is what you're going to have. So after getting this one, now let's expand this. This will give us what? Y squared minus 2xy plus x squared, right? The expansion of this. Then this gives us minus 4xy. Can you see that? Now you realize that this and that are like terms. Yes. So this negative 2xy and the negative 2x, I mean 4, this becomes positive, right? Negative times negative, that gives you positive. So if I subtract this from this, you are going to have y squared plus 2xy plus x squared. So this is what you're going to have. You know, I can write this. Look, I can write this is a perfect square. So I can write this one as x plus y squared. If you factorize it, this is what you get. It's a perfect square. Yes. Now, the question was specific that we should identify all the region of points at which the PD is hyperbolic. In fact, you realize that this one, in this case, it's not numbers like the one we did previously. So when it happened like this, what you're going to do is very simple. What you need to do here is that you check, this is a squared, right? It means that no matter what, this one can never be elliptic. But even if you put negative number here and you square it, you still get positive. So that makes it hyperbolic. Good. But you can also get parabolic from this, right? Where you choose x to be 0, y to be 0, you get hyperbolic from that. So we identify this one in the graph, okay? So this is my y and this is what? X. So what you are going to do here is that let's consider this to be, let's say, parabolic, okay? Yes. So let me do it here. If this is parabolic, it means that you are going to have x plus y square equals 0, right? We take square root on both sides, meaning that the square will go. So even if you put plus or minus here, plus of 0 is still 0, minus of 0 is still 0. So what you are going to get here is that x is equal to negative y. Good. So if I want to draw this, the curve goes this way. So that is either y equals negative x. You know this one, let me write this well. This looks nicer. Y equals negative x. So now, we want to determine the region where the thing is hyperbolic. The meaning of what I've done here is that the only region where it is not hyperbolic is when y is equals to negative x. Y equals negative x or x equals negative y. That's where the region is not hyperbolic. Is that okay? It means that the rest can become what? Hyperbolic. So in that case, what you do here is that if it is hyperbolic, it means that x plus y squared should be greater than what? 0, which is certain. So if that one should be greater than 0, and I'm solving inequality, you know what happens? What happens here is that if you take square root in inequality, you don't even take square roots in the first place. But if you take square root, you are just going to get one solution, which is y is greater than 0. I mean, y is greater than negative x. Is that okay? But what happens here is that you can get y being greater than negative x or y being less than negative what x. So that is how we solve inequality. What you do here is that either there's a square here, so either it's y being less than negative x or y being less than negative x. What this means is that whatever you put here, you still get positive. If I put negative, so if I pick 1, 2, 3, okay, let me write this one. Y is equals to negative x, okay. So if I pick 1, 2, 3 here, negative 1, negative 2, then getting to the y side, that's what it's going to be. Let's test whether what you are saying is true. So if you say that y is less than negative x, means that if I put negative 1, or let's say, let me pick positive. If I put 1 here, that will give me negative 1, right? If I put 2 there, that will give me negative 2. If I put 3 there, that will give me negative 3 for the first side. Means that this place is certain because indeed y is greater than negative x. What it means is that even if I put the negative there and I square, it still get positive. So the region in which these two functions, or the region in which the points at which the PDES is hyperbolic, is this place and that place, except y equals negative what x. That's what I want to say. Except y equals what negative x. So that's how the conclusion is going to be. Thank you very much for watching. Please try to subscribe and share to your colleagues.